Assalamualaikum and hi to both panels, Madam Rosina binti Abdurrani and Mr. Nuzaki bin Ihsan. My name is Muhammad Ashraf and my supervisor is Dr. Muhammad Nur Azmi bin Abata. Today I'm going to present about my final project 1 titled Finger Exoskeleton for Finger Stretching Application. And this is the outline that I present after this. So the first part is introduction. So basically what I did in my final project 1 is improve the finger exoskeleton prototype developed from previous study. Then I determined the actuator, motor and material for fabricate the device. After that, I developed a control system for the device. Then after I select the motor for actuator, I need to analyze the torque first. Before I analyze the motor, I've designed the torque experiment for motor comparison from previous study. In my final project 2, I will be developing a total of 5 finger exoskeleton based on the selected motor and material. Then I analyze the performance of the device. So, what is stroke? Stroke, also known as brain attack, occurs when brain receives less oxygen due to some blockage in blood flow or rupture of an artery to the brain. Statistically, in Malaysia, stroke disease led at top 5 as the cause of death and kept increasing throughout the year. All the stroke survivors will undergo a recovery process from mobility dysfunction, body balance, memory loss, cognitive function, and sensation loss. It is proven that repetitive stretching can help impair hand of a post-stroke patient by developing a motorized device, such as finger exoskeleton. Moving on to literature review. It is found that several studies have developed hand exoskeleton to help hand-impaired people rehabilitate. Essentially, finger exoskeleton is divided into 3 major parts, which are actuator mechanism, control system, and material use. Many finger exoskeleton use various types of actuator. To power the actuator, the motor must provide enough output force to achieve better performance. To compare, the maximum force exerted in normal daily life activity, such as grasping and lifting object, is under 22 Newton, and maximum torque at index finger with 0.015 Newton meter at MCP joint. Normal human index finger flexion and extension should achieve 0 degree to 80 degree at DIP, 0 degree to 100 degree at PIP, and negative 20 degree to 90 degree at MCP. Now let me talk about some previously developed finger exoskeleton such as RML Grove V2 by Zhu et al. This device uses series elastic actuator SEA as actuator mechanism which powered by DC motor. It uses linkage type force transmission, a microcontroller, and battery integrated for portability goal. The device can bend 38 degree at MCP joint. It is also lightweight, low cost, compact, and produce high output force of 20 Newton at each fingertips. However, the device exhibit noisy sensor reading out to measure friction force and have deformation linkage. Next is N-shaped finger exoskeleton developed by Su et al. This device uses linkage mechanism to transmit power actuated by a stepper motor. The range of motion for this device can achieve is 44.2 degree. They fabricate the device by using 3D printer, which use PLA material to be low cost. The use of PLA plastic material is suitable for the device purpose based on the simulation, and due to the material, the device weighs less than 45 grams. Torque produced is 0.3 Newton meter, but the efficiency of the device is decreased due to friction force between the 3D parts. Handmade was developed by Sanderson et al. Also used linkage force type transmission. The device uses linear actuator for moving the device, and due to a costly actuator, the maximum force exerted by the device is 50 Newton. This device uses small actuator, battery integrated, and microcontroller that can enable wireless control via Bluetooth. The linkage of the device has been developed to allow 90-degree movement at MCP and 100-degree at PIP. The device is weighed around 340 grams. Next, in terms of transmission mode, hand exhaust beta developed by Marconi et al. Use cable-driven mechanism to transmit power. The device uses DC motor to actuate and connect to a boarded cable transmission system. It is portable due to actuator can be placed far away, but this transmission mode lesser than direct transmission mode due to friction and weak force transmission. Moreover, the material used for the device is metal, which causes discomfort for user, and is heavy, which weigh around 480 grams. So this is a summary table of previously developed finger exoskeleton with the information of force transmission, degree of freedom, actuator, motor, material use, and range of movement of the device, and also torque. A total of 4 finger exoskeleton is to be studied, and the fifth is the previously studied finger exoskeleton developed by Dr. Azmi and previous student, in which I will improvise in my project. So there are 3 problems that inspires me to do this project. First one is the device is difficult to design due to many degree of freedom, which involve 21 degrees of freedom, which is very, very complex. Second is that it is expensive to develop the finger exoskeleton due to the need of powerful motor for actuating the device. Third is that the performance of the device is reduced due to the big size of an exoskeleton and it is hard to use. Thus, my objective for the project is to develop a hand exoskeleton that can produce enough torque for finger stretching application while reducing its size. Second objective is to assess and analyze the performance of hand exoskeleton once I have done fabricating a fully functional hand exoskeleton. So my study will focus on investigating finger exoskeleton output force, whereby it should give adequate force for finger exercise by involving only 1 degree of freedom movement, which is extension and flexion of finger movement. The limitation to the study is using small and low cost DC motor, whereby it frequently produces low output force and torque. As for material, PLA plastic is more brittle than ABS plastic material. Next slide will be the methodology of my study. There are 5 total phases in my study. The first phase starts with literature review on existing finger exoskeleton. Based on the previous studies, output force, actuator, motor, and material to use in the study are known. In phase 2, I have selected Pololu DC motor and Meson DC motor for torque analysis, and PLA plastic material for developing the finger exoskeleton, and linkage type force transmission for mechanism. Then I designed the thought experiment for thought analysis. Together we designed the 3D parts for thought experiment. All the 3D parts will be designed in SolidWorks 2020. Next phase, I developed all the parts that were designed in previous phase. There are 5 total parts that need to be 3D printed by using the PLA plastic material. Then I developed coding using Simulink MATLAB for motor control system. Phase 4 will start by set up the torque experiment and I assemble all the components. Then the torque is analyzed and compared. Phase 5 will be fabricating, then analyzing the hand exoskeleton based on the selected motor, which will be done in my final year project too. Now moving on to part 4, which is my preliminary result. As you can see, this is the setup for my thought experiment. The motor is connected to the circuit shown at the right side figure. The experiment begins by hooking the weight scale to motor shaft extender. Then the motor will revolve by rotating the potentiometer to max, and the hook of the weight scale is pulled. The weight pulled by the weight scale is then obtained and then tabulated in the next slide. To take the average weight pulled by the motor, I conducted 5 test numbers. The result is the average weight pulled by Pololu DC motor is 0.296 kg. Meanwhile, the average weight pulled by the Maxon DC motor is 0.254 kg. And from the data obtained, the torque can be known by using torque formula. It is calculated that Pololu DC motor produces 101.6 Newton millimeter torque, meanwhile, Maxon DC motor produces 87.18 Newton millimeter torque. To conclude, Pololu DC motor produces more torque and force than Maxon DC motor. Thus, I select the Pololu DC motor to develop a finger exoskeleton for my future study. Moreover, Pololu DC motor is good for developing the device due to its small size, making my device more portable. I think that's all for me. Thank you.